Welcome to video 1.0, and this is the beginning of chapter 3. So just as a review of what you know, there are physical forms of matter, and they are either solids, liquids, or gases, and we call these states of matter. There's also plasma, but for our purposes, we're going to go with solids, liquids, and gases. Remember that solids have a form of matter that have a definite shape and a definite volume. Liquids are a form of matter that have a definite volume but take the shape of the container. So what that means is a solid and a liquid both have a definite volume, but a solid retains its shape and a liquid takes the shape of its container. Because they both have a definite volume, that means that they're going to be very incompressible, which means that if I try to compress it, it's not going to work very well because it has a definite volume. However, gases are very different because gases have no definite shape or definite volume. They're going to expand to fill their container. So if I have something that is a gas and I let it out into a room, it will expand to fill that whole room. And vapor is a gas. But what vapor is it's a gas when that substance is normally a solid or a liquid. So water vapor. Typically water is a liquid at room temperature. But it would be when it's a gas, that is kind of weird that it would be a gas when it's room temperature. So water is kind of an odd substance in the fact that it can be a gas at room temperature. Like in the morning when you see water vapor coming off of a creek or a river or a pond or a lake, or when you have when you're boiling something, you're vaporizing that because of an external force. So now we're going to talk about physical and chemical properties. So a physical property is a characteristic that can be observed or measured without changing the sample's composition. So if I say the leaves are green, or if I say the door is brown, or if I say the desk is hard, that's a physical property. So the color, what state of matter it is, its melting point, its boiling point, its density, those are physical properties. So it identifies the substance. An extensive physical property is dependent upon the amount of substance present. So that's length, mass, volume. An intensive property is independent of the amount of substance present, such as the density. So extensive properties depend on the amount. Intensive properties are internal. Density, how many kidneys you have is an intensive property. The color of your eyes is an intensive property. An extensive property would be how much you weigh. That depends on how tall you are. So extensive, it's dependent upon how much of the substance is present. Intensive is not. Chemical properties, on the other hand, are the ability of a substance to combine or change into one or more other substances. So iron rusting. That's like an old car that's formed to rust. Copper turning green in the air, the Statue of Liberty. It's oxidizing. It used to be copper colored, now it's green. Anytime it changes, that is a chemical property, and it changes the identity of the substance. So, this is going to be one of our most important ideas, is that substances can change forms. So, in a chemical property, those are going to change with specific environmental conditions, such as temperature or pressure. A physical property can change also. So physical properties, if they change, what I meant by they can change also is basically I can't change it other than to change like its state of matter. So when I change the physical property, that means like something is malleable. I take the piece of paper or the piece of tinfoil and I mold it into something else. Or I cut the piece of paper. Or I cut hair. And that's a physical change or a physical property. A chemical property is something that's going to form something new, or it's going to change color or change temperature. So physical changes, and this is important, they alter the substance without changing composition. So that would be like cutting hair, that would be cutting a piece of paper, that would be separating something, but it doesn't change the composition. A phase change transition of matter from one state to another, going from ice melting into liquid water, that's a phase change. Have you actually changed the composition? No. So that is a physical change. So boiling, freezing, melting, and condensing, those are phase changes. Chemical changes involve one or more substances turning into new substances. That's a chemical change. So if you see the word decompose, rust, explode, burn, or oxidize, those are all chemical changes. And these are our 4 evidences of a chemical change. Change in color, change in odor, so if something smells good, like you're cooking cookies. Change in temperature, or formation of a solid or a gas from a liquid. That does not include phase changes. Remember, phase changes, state changes, are physical because you're not changing the composition. But if you form a solid or a gas from a liquid, that would be a chemical change.